Hi guys, for this video I will solve this circuit using nodal analysis. The given circuit consists of 50-volt source and 6 amperes independent current source. We also have 3 connected resistors, designated as R1, R2, R3. The value of R1 is 10 ohms, R2 is 2 ohms and R3 is 5 ohms. Our goal is to find voltage and current flowing at R2. First thing to do is find the nodes of the circuit. This first node here is the one we are going to use later. The node here at the bottom will be our ground, which will be our reference. Let's consider the voltage V here as 0. Our next step is to designated points in the circuit. We have points A, B, and C. At node B, we will use Kirchhoff current law, which means that the summation of all current at point B will be equal to 0. Let's assume that the flow of current at R1 denoted as I1 will be entering at point B, which will have a positive sign. The current flowing from R3 denoted as I3 will also be entering point B, since it is consistent with the direction of the independent current source, which will also have a positive sign. Next is the flow of current at R2 denoted as I2, which in this case is leaving point B, and that means it is a negative sign. So we have the summation of current at point B, which is I1 plus I3 minus I2 is equal to 0. Guys, we already know that to solve for I, it is equal to V divided by R. So it means, I1 is equal to V1 over R1. But to solve for V1, the voltage at R1. It is the voltage difference between higher potential and lower potential at point A and B. Assuming that the VA voltage at point A is higher potential and VB is lower potential. I1 is equal to VA minus VB all over R1, but VA is equal to the voltage source, which is 50 volts. So I1 is equal to 50 minus VB all over R1. That's how we solve the currents in the equation. Let's proceed. I1 plus I3 minus I2 is equal to 0. So at I1 we already have 50 minus VB all over R1. We go now for I3, but since it is a current source, we already have its value 6 amperes. We just write it here as plus 6. Let's go now for I2. It is the difference between higher potential VB and lower potential, which is the ground. So I2 is equal to VB minus 0 over R2. We already know that the potential at ground is equal to 0, that's why we write VB minus 0. Or simply VB over R2. Our equation will be like this. 50 minus VB all over R1. Plus 6. Minus VB over R2 equal to 0. Plugging in the values of resistors. We have 50 minus VB all over 10. Plus 6. Minus VB over 2 equal to 0. Now we just solve it algebraically. Multiply the equation by 10. So here multiplying it by 10, the 10 here will be cancelled out. 50 minus VB. 6 times 10 will be 60. So plus 60. Then here VB over 2 times 10 will be 5 VB. Simplifying 50 minus VB plus 60 minus 5 VB equal to 0. Adding similar terms. 50 plus 60 will be 110. Negative VB minus 5 VB will be equal to negative 6 VB. 110 minus 6 VB equal to 0. Transposing minus 6 VB. 110 is equal to 6 VB. Dividing both sides by 6, we will have VB is equal to 110 over 6. Which is equal to 18.33 volts. To solve for I2, it is equal to VB divided by R2. 18.33 divided by 2 is equal to 9.17 amperes. So that's how we solve a circuit using nodal analysis. I hope you learn again something. See you next time.